In this question, we're required to build a table of reduction half reactions from the following evidence, and in the questions deal with hypothetical substances, but one actual substance, one actual reaction. The half reaction that's given to you is the lead-4 oxide and sulfate and acid, and a couple of electrons, and you get these products. And it's in your data book as 1.69 volts as the electrical potential for this half reaction. Now it reacts spontaneously with the X substance, the X solid. We know it's spontaneous because the electrical potential is 2.00 volts, a positive value, which means it's a spontaneous reaction. Now, if it's a spontaneous reaction, that means this half reaction is the oxidizing agent, and X metal is the reducing agent, and so therefore the X metal has to go below the oxidizing agent, and so therefore I'll put the X down here. So this is going to be your X metal, and then we have an X ion and an electron to round out the reduction half reaction. Now, to determine what the now this is going to be the cathode, and that's the reduction potential for the this is the reduction potential for the that goes on at the cathode. The anode then is going to be the X. And that's what we're looking for. We're looking for the anode. And I've just taken the liberty here of writing out these little equations here, where the electrical potential of the cell is equal to the E cathode minus the E anode, and so on. And this here is just a manipulation of this equation, where the E anode, which is what we're looking for here, the electrical potential for the anode, is equal to the E cathode minus the E cell. Now, the electrical potential of the cathode is 1.69, and subtract the electrical potential of the cell, which is 2.0. And so the reduction potential for this half reaction is negative 0.31. Okay, now we're looking at the next reaction down, which shows X this time, the X metal, this time reacting with Z ion. And so therefore the Z ion has to position itself above the Z metal. Now, it could indeed be that Z could actually be, above this reaction here, and so this is why you should write this stuff out in pencil, because if that's the case, then you have to erase it and then just write it above this reaction. So I'm just taking a guess here that it's going to be below, but it could just as easily be above. It depends on what value I get here. It depends on what value I get here. Just to remind you, is because when you look at your data book, the strongest oxidizing agents have the largest electrical potentials for their half reactions, and as you go down the page, so weaker oxidizing agents, then you also get a decrease in the electrical potentials. And that's what we're wanting to do here, create a table of reduction half reactions, and we want to see our numbers starting to go down. So X, which reacted with this oxidizing agent, is predictably a smaller electrical potential than this. So far the X and the lead-4 oxide half reaction seems to be positioned okay. We know then that Z is going to be at least greater than negative 0.31 volts. Now in this case, the Z ion is acting as the cathode, the X metal is the anode. And so I need to calculate what the electrical potential of the cathode is. And so I'll use this little reaction here. The E cathode is the E cell minus the E anode. The E cell is given to me in the question as 0.19, and minus the E anode, which is this guy here, plus negative 0.31. And so that comes to negative 0.12. Okay, so a good call by me is that the negative 0.12 is certainly less than positive 1.69. So therefore, the Z reduction half reaction definitely goes below the big one at the top here. Okay, the third reaction shows the Z metal reacting with P2. Now P2, which I have space here, so I'm going to put P2 here, but again, P2 could be above this one. It depends. But you know, again, you should write this out in pencil in case you have to do some erasing. So the reduction half reaction here, as really drawn out from the question, is like this, and I'm looking for the E cathode again. So it's this reaction. Now it's worth definitely pointing out that this is definitely a spontaneous reaction as indicated by the positive value of the electrical potential of the cell. So it's 0.88 in the cell minus the anode, which is negative plus negative 0.12. And that is positive 0.76. And so that's our table. That's our table of reduction half reactions. That's our half 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, 0.6,